Hello guys, welcome to another video. So in this video, I'm going to talk about starting from object-oriented programming, right? So you have computer programs. They can be said to consist of code and data. A program that is organized around code is said to be process oriented, and code which is organized around data is said to be object oriented programming. So in object oriented programming, the main concept is that of abstraction. So as human beings, we try to manage complexity through abstractions. Let's take for example a car. We don't want to think of a car as consisting of thousands of parts, but we want to think of it as a single entity that we can use to drive us to destinations where we want to go. We don't think of a car as consisting of an engine or transmission or braking systems. We don't want to deal into how they work. All we want is visualize it as a single abstraction called the car. And we say that abstraction has a hierarchical classification. So we say that a car consists of a transmission system, which in turn, or a sound system, which in turn can be divided into actual devices like CD device, CD radio, CD player, etc. Right? So these are hierarchical classifications of abstraction of systems help us to understand or these hierarchical abstractions of such complex systems like a car is can also be applied to a computer program, just like how human beings want to think of these the abstracted view of entities like car and object-oriented programming. Also, we can apply the same hierarchical abstractions to a program, right? So, on based on that, there are three principles of OOP. We'll take the first one called encapsulation. So this is the mechanism that binds code and data into a single unit and prevents it from being manipulated from outside. So it is considered to be a preventive or a protective wrapper. So entities outside do not affect those inside the wrapper, right? So let's say, for example, take the transmission system. It's only affected by the shift gear. So it encapsulates details about how much you are accelerating, the surface on which you are driving, and the position of the shift lever. So the only way to manipulate these data is through the gear shift lever. No other way that you cannot move the windshield wiper, and that doesn't affect the transmission system. So that is called encapsulation. So the same encapsulation can also be applied to programming, right? So in Java, the basis of such an encapsulation is a class. So a class encapsulates code and the data that it operates on. Right? So in a class, you have members of the class, that is code and data, as members of the class. Uh, the the data in a class member is called member variables, and the code itself is called the member methods. So because we say that the class, the code and data in a class encapsulate complexity and also access, you have types of access modifiers. You can say public interface, which could be accessed by code that is not the member of a class, or you can have a private members which can only be accessed by parts that are part of the program. So you have the concept of a private and public. Then you have inheritance. So inheritance is by a mechanism by which one object acquires the properties of another object. let's say for example dog, right? Dog is an animal. So if you model dog as a subclass of an abstract class like animal, so dog is going to get the properties uh, of an animal, and dog is from animal you can have another subclass called mammal, and the dog could be a subclass of the mammal as well, right? So in essence, all the characteristics of mammals are inherited by the dog, and the mammal inherits all the attributes and even methods of animals. And such a hierarchy of subclasses is called a class hierarchy. So you also say that inheritance interacts with encapsulation. And we say that inheritance interacts with encapsulation, right? And then you have the concept of polymorphism. So polymorphism means many forms. Let's say that you have a stack, right? So the stack class, you can apply several operations on the stack class, and depending, and the stack could be of what kind consist of integer values, or floating point, or string. But you do not write different routines, different methods for each type of data that the stack contains, but you write a single interface containing multiple methods. So, and also it's possible to have a generic interface for all these related activities. So it's one interface, multiple methods. So similarly, this can also be extended to the analogy of a dog. So, let's say the smell of dog is polymorphic. If it smells food, then it will salivate and run to the container consisting of food, right? So what is being smelled? The difference is what is being smelled is operated upon the dog's nose. So if it smells a cat, then it's going to run after it. So that is also called polymorphic. So polymorphism, encapsulation, and inheritance work together in object-oriented systems. Thank you.